this computer. All right, we are recording. All right, so with freezing lakes, let's get started. So explain what happens as the lakes freeze. I did not put a Padlet together for you today, so what I would like you to do is put in the chat. Just in the chat, tell me what happens when the lakes freeze, step by step. Just a quick synopsis of what happens when the lakes freeze. Just tell me what you know about the lakes freezing every winter. I know a lot of you have been around and lived in Wisconsin your whole lives. You've been around frozen lakes, but I want you to kind of think about what happens when the lakes freeze. And don't just say, well, the lakes freeze. So tell me, tell me what you think happens to the life underneath, because I know some of you guys have seen people ice fishing, so you know that people drill into the water and fish for those fish that happen to still be just kicking around looking for food. So go ahead and just tell me what you think happens and put it in the chat, please.
We're not really in chat. A lot of us aren't logged in.
Oh, that's right. You guys aren't logged into the Zoom. So, well then, that's different. So I got people at home. Just go ahead and raise your hand if you want to give me like a quick fact of what do you think happens to the ice or to the water as it freezes over the winter. Yeah. Go ahead, Jacob. I thought you raised your hand. Okay, that could be one thing. Go ahead, KP.
I think that you get a pretty thick layer of ice, but underneath the fishies are still swimming around.
Okay,
Living their life.
that's right. They're still living their life. This is what I. So I got people at home saying water turns into a solid. Thank you very much. Surface of the lake freezes over and insulates the plants, fish, and other biotic factors below. Nice. I got another one saying top of the water freezes into ice and the plants and animals probably go dormant or try to conserve their energy. Interesting. I like some of these explanations. Anyone else have anything to add to those? No? Okay. Well, so here's some of the questions I want you to kind of think about as we're going through today's slide. So how do oxygen and nutrients get to the deepest part of the lakes? If you ever thought about that, you're like, hey, well, if the ice freezes, how can we get stuff to all of those things all those life forms underneath the water that are still kind of alive? And it's many months before they're going to get any sunlight or any photosynthesis happening because there's a lot of there's not enough sunlight getting to them. And why does water density change every season? And when we talk about water density, don't worry. If you have like a kind of slight idea of what water density is, we're going to discuss why things get denser with a change in temperature. Okay, but we have to kind of start with what is happening to water. So let's discuss some of these basic properties of water. So in the chat, or just go ahead and raise your hand and let me know, what are the different states of water? Go ahead and put that in the chat for me at home. And for those of you here, go ahead and raise your hand. What are the different states? Give me one state, Tanner. Huh? Liquid. Hey, perfect. Liquid. I got liquid at home here in class, and I got people at home saying liquid, solid, and gas. All right, awesome. You guys have nailed it. All of you have an idea of what the different basic states of water are. And that's pretty much the different states of matter. When we're talking about different states of matter, water has those three different states. Okay? So you've talked about liquid in water. And for us, gas, that's water vapor. And then as far as a solid, it's ice. And we've seen all these three things, but ice or water is extremely special, okay? So what's so special about solid water? Well, can anyone in here or anyone at home tell me why ice or solid water is so special? Think about that for a second. What? Okay, the temperature freezes. So a lot of different things freeze at different temperatures or become solid at different temperatures. But what makes ice specifically, frozen water, so special? So you can see with the chat. Ah, go ahead. All right, so someone said ice is less dense than water. Yes, that is that is correct. So if you think about it, when things become a solid, if you ever taken chemistry, anyone in here taken chemistry? No? So when you take chemistry, when you precipitate a solid out of the water, what happens to all those solids that come out of the water? Do they sink or do they float? If you ever done a reaction where something you take something out of solution, when those things come out of solution, they become a solid in that liquid, those things usually sink. And they usually they don't ever float. They go to the bottom of the water. Most things when they come out of a liquid, they'll sink right to the bottom of whatever liquid they're in. Ice is completely different. Ice, when it becomes a solid, it becomes less dense. So let's talk about water density. So the definition of density is the degree of compactness of a substance. So let's say that all of you in my classroom right now are air molecules, okay? So let's say that the people in the hallway, let's say there's like 100 plus people in the hallway. Not really great right now because of COVID, but let's say that there's 100 plus people in the hallway right now. There's only about, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of you in here right now. Which is more dense, my classroom or the hallway? David, the classroom, why? So there's what? Well, so it's less dense. So here's the thing: there's less people in the hallway, right? So that means it would be less than there is in the hallway, because I said there was 100 people in the hallway. So if there's 100 people in the hallway, that means there's more air molecules out there. Now, let's think about this. I'm going to use the same area now. Mr. Austin's class is about the same size as my class next door. All right. If I put like 50 people in there and we still have 15 people in here, which classroom has more density of people? Good. It'd be Mr. Austin's class. And if you think about it, if there's more people, more dense people in there, which is heavier, the people total in Mr. Austin's class or the 15 people in this class? I mean, we're all about the same size. I mean, none of us in here are like 600 pounds, right? I mean, I'm like 200 pounds. I'm pretty heavy, but I'm nowhere near 600 pounds. So all of them, let's say they're about a buck 50 or less, because they're freshmen. They're little. All right. So let's say, like, if you have 50 people in there, it's going to be more dense. So that means the more densely packed a substance is in an area, the heavier it is. So that's the compactness of a substance. The more dense something is, the more compact its molecules are. It means there's more packed together, so it's going to be heavier. Okay? Usually liquids are less dense than solids, like molten rock. Once, let's say, molten rock solidifies, it's going to be a lot more dense. That solid rock is going to be dense, and it's going to sink. Again, we've talked about what's so special about frozen water, and someone at home already told me that it's less dense than the liquid water. So just like I talked about here, let's say you've got two areas of molecules here. Let's say this little 3-inch square is however many molecules of water you have in an area. So if you have more molecules in an area, it's going to be more dense, it's going to be heavier. So what do you think is going to happen to a densely packed bunch of water in the lake? Is it going to float or is it going to sink? If it's densely packed, it's going to sink. There you go. If it's going to be densely packed, it's going to sink. The only time that it floats is when it becomes ice. Now, when water freezes, the water molecules line up in a hexagonal structure. Remember this, in a hexagon. How many sides does a hexagon have? There you go, hexa means six. 6 sides in a hexagon. As water freezes, the hydrogen bonds push the water molecules, I'm going to move this out of the way so you can see it, push the water molecules farther apart from each other, increasing the intermolecular space, resulting in expansion. So when ice solidifies, it lines up like this in these hexagonal structures. And because of that lining up, it's going to push those molecules away from each other, which is why it becomes less dense. If you look at this, this is liquid water on the left. The liquid water on the left is always moving, and it's always kind of just bunching up together. It's going to be a lot more dense, but once they line up, they become this pretty structure, which when you guys see ice freeze, sometimes it freezes in this really cool structure, which is why snowflakes are shaped the way they are. They automatically line up in a hexagonal structure, which is why you get those cool shapes and different formations of a snowflake. So when we talk about lake stratification now, actually I'm gonna go back there, I'm gonna let you guys kind of write this down, okay? When we're talking about density now, the tendency for many things is for like dense items to kind of bunch together. So let's say you have a bunch of items that are, or a bunch of molecules that are about the same temperature, which means they're about the same density, they're going to be in the same level. If it's lighter water or warmer water, same thing, it's going to be in a higher area. That's when we're going to talk about lake stratification. So let's play this video really quick and we can figure out, I want you to kind of visualize some of the ideas about lake stratification. Actually, people at home, give me a thumbs up if you can actually see the video and hear it okay. Okay, you guys can hear it okay too? Perfect. All right, excellent. Thank you guys.
Imagine you're swimming at the lake on a hot summer day, and your friend says, "Hey, I bet you can't touch the bottom." And you're like, "I bet you I can." So you take a deep breath, and you swim down and down and down, and suddenly it gets cold, and you stop. What is this? What's going on? You've just experienced something that's hugely important to everything that goes on in the lake. It's called thermal stratification. After you get back to the surface and catch your breath, you think, why is it warm up here but cold below? Is it always this way? Let's run an experiment and find out. What we have here is a model of a lake cut in half down the middle. We've taken all the warm water, dyed red, and moved it to one side. The cold water, dyed blue, is moved to the other side. In the middle is this barrier that keeps the sides separate. Now let's remove the barrier and watch what happens. As you can see, there's a lot of movement between the two layers as they come together. But look, the warm water has settled out on top. Let's try the experiment again. This time we put the cold water on the left and the warm water on the right, just to see if it makes a difference. Once again, the warm water settles out on top. What's going on? To answer that, we need to take a look at the physical principle driving the whole show: density. Density is the amount of stuff in a given volume. In our case, that stuff is water, and that volume is this glass beaker. This beaker is filled to the brim with our cold water. Let's see how much it weighs. 166.2 grams. Now we've emptied the cold water and refilled the beaker with the warm water. And the warm water weighs in at 165.1 grams, a little bit less than the cold water. We can calculate the density of these two samples by dividing the mass by the volume. First, we need to correct our previous measurement by subtracting out the mass of the empty beaker. This gives us 116.2 grams for the cold water and 115.1 grams for the warm water. Now we divide by the volume of the beaker to get a cold water density of 1.00 grams per milliliter and a warm water density of 0.99 grams per milliliter.
Don't worry, I'm not going to be making you do any math here today or for the test, so you're good.
In reality, it's a very small difference, but that small difference has a big impact. It allows the warm water to essentially float on top of the cold water, and it keeps the two layers from mixing together. So what affects the temperature and in turn the density of the water in the lake? You might think the temperature of the air surrounding the lake is the answer, but really the biggest impact comes from the sun. As sunlight enters a lake, it warms the surface water, making it less dense and lighter. As the surface water begins to float on the cold water below, a transition zone forms where it changes from warm to cold very quickly. We call that the thermocline. Remember, thermal stratification in lakes is as ordinary as the changing of the seasons. And in fact, it does change with the seasons. But we'll save that for another time. For now, know that warm water, cold water, and a thing called density set the stage for the behavior of, well, really everything that goes on in a lake. It's very important.
All right, so stop. I don't want to see it again. All right, so let's see. For those of you who likes to actually swim in the lake, who likes to swim in the lakes? All right, so have you ever tried to go to the bottom and have you ever felt the really quick temperature change when you get to the bottom of the lake? That's crazy, right? It's like super cold. I mean, this happens in everything. When I used to, I think one time I was snorkeling in Hawaii, and it was nice and warm water up at the top of this one area, and then I went down below where that water was becoming really, really deep and blue. All right. And I got to that little deeper area, and then all of a sudden it was super cold. I'm just like, oh, I felt uncomfortably cold because, well, first of all, I have this fear of being eaten by a shark, even though there probably wasn't any sharks in the area. I just had this weird fear ever since I saw that movie Jaws when I was a kid. But it just got really, really cold. And that was one of the things that kind of stuck with me, is that it was really cold once I got past that certain area. And this is before I was studying this stuff, and I was just like, oh, okay, now it makes sense. This is the thermocline. That huge, quick temperature change is when it becomes warm, that floating warm water on top of the cold water, that change is that thermocline. And to stratify, here's your vocab word: stratify, to form or arrange in strata or layers. We know that these different lakes have different layers, or like the deeper the lake is, it's going to have more layers. To better understand how stratification affects the lake, we just watched the video, so we're good. So in the summer, there are 3 major stratification zones. All right, so this is what you should have. I think you have to write these down in your notes. Your epilimnion, epi means top layer, the warm upper layer of the lake. That's the epilimnion. So think about, there was this little machine back in the 80s called the epilator, where it used to like take the top layer of hair off of your skin. It's kind of like a shaver. So when you actually think about think about the top outer layer of your skin. Epilimnion, the top layer of the lake. Now, once that thermocline hits, that's the change in temperature, that thermocline, thin layer of the lake where the temperature drops dramatically. It's going to drop really, really quick. You will definitely feel that temperature change if you dive deeper into the lake. And then once we get to that bottom layer of the lake, that is the hypolimnion. If you think about the word epi and hypo, who's ever heard of a hypodermic needle? Hypodermic needle goes underneath the skin to give you an injection of for whatever. So hypolimnion, below or beneath. The lower layer of water, usually low in oxygen. And we're gonna talk about, well, how does the lower how does that hypolimnion ever get oxygen to begin with if there's hardly any oxygen down there? It's usually lower oxygen levels because remember that most of these plants and animals live closer to where the sun is. So they live on the epilimnion, specifically closer to the edges. So how does the hypolimnion get that oxygen? So here, this important note here is temperature and density are directly related. So the warmer something is, the less dense it's going to be. Those molecules have spread out because it's warmer, and it's going to sit on top of the colder, more dense, cooler water below. So we are now going to start talking about the different times of the year once we see and like the lake's freezing, and they go through something called lake turnover. All right, and it's lake turnover happens because of the changing of the temperature. And in the summertime, this is what we normally see. These are the main layers of the lake. Your epilimnion is there, your thermocline is there. You're gonna feel it nice and cold when you dive deeper. And if you actually get to the bottom of the lake, let's say it's an 18-foot lake, and you get to the bottom there, it's pretty deep actually. And then you're gonna actually feel that temperature change really severely once you get to the bottom. Top layer is gonna be warmed by the sun, and that's going to be your epilimnion. The bottom layer is the coldest. There's hardly any thermal energy reaching it. If you actually sat on the bottom of the lake and you looked up, you could barely see the sun. All right. You'll see maybe like this little tiny bright white dot, but it's not enough to give plants down there a lot of energy in order to photosynthesize. So there's hardly any thermal energy reaching it. I'm going to put that back there while you're writing notes. So remember, we're talking about lake turnover now. We're turning the lake over because every season it's going to be a little bit different. Remember, as the sun kind of moves into a different position in the different part of the year, you're going to get less thermal energy, less sun on that lake. So fall turnover is going to happen. And so what's going to happen is that top layer of the lake is going to get colder. At 39 degrees, water is at its most dense. Think about the temperature here. 39 degrees, water is the most dense. And because it is at its most dense, that water is going to sink. Let's say that the temperature below is about, let's say, 45 degrees, 50 degrees at the bottom of the lake. That means 39 degrees, it's going to be super dense. It's going to make its way to the bottom. It's going to sink to the bottom of the lake. What that means is anything at the bottom is going to get pushed up. Okay, and that's what's happening with the overturning of the lake. Warmer water from the bottom will rise, causing mixing. And remember that since that was at the top, the water on top of the lake is highly oxygenated. That's how the oxygen gets to the bottom of the lake. This mixing in the fall. All right, so any nutrients that were up at the top or at the bottom actually, any of the nutrients gets brought up to the top of the lake, and oxygen gets brought down to the bottom of the lake, causing a good number, a good mixing of nutrients and oxygen. Okay. So far, so good? Okay. So now it's winter. Top layer freezes at 32 degrees. It's less dense now because of that hexagonal structure that has been created because of the freezing. And because of the expansion of that ice, it is now less dense and it sits on top of that liquid water. This is why water is cool, all right? Water is one of those special things that this planet has. We have liquid water, and it does these things to help us survive. Now, that 32 degrees solid water is now just going to sit at the top, and anything below that is going to continue to just sink to the bottom. So basically, if you're thinking about it, the bottom of this lake now is going to sit right around 39-ish degrees, more or less. But it's going to stay that way. It's going to stay insulated because of the fact that, well, water, the frozen water at the top is going to keep that that temperature pretty steady down below. There is winter stratification, but it's generally pretty stable due to no wind and there's no heating from the sun. That ice is pretty much reflecting everything off of that lake. It's nice and white. And so it's going to reflect all that energy back into the atmosphere. Remember that darker water, that deep blue water, actually absorbs a lot of heat. But once it freezes into ice, it's going to reflect it back into the atmosphere. And that is something called the albedo effect. We'll talk more about it when we talk about climate change. All right. So now it's winter. Right now it's late spring right now, right? So we've already lost a lot of all of our ice that were on top of the lakes. And so we've already experienced a lot of spring turnover. And so what happens is that ice melts. Once the air temperature on that ice melts, it's going to get a lot more air temperature on it, or sorry, some of that thermal energy from the sun. It's no longer going to reflect because that water now is starting to melt, and it rises to 39 degrees. Once that temperature rises to 39 degrees, that water is now going to sink to the bottom of the lake. Wind mixes the surface water along with the sinking water, and so all of that water that was underneath now gets pushed back up to the top. Sun will eventually heat the water at the surface, and then you are going to re-stratify in the middle of summer. So this cycle goes over and over and over again, and it brings you the nutrients from the bottom of the lake, and the oxygen that's on the top is going to be brought to the bottom of the lake. So yes, there is low oxygen levels at the bottom of the lake, but it is replenished slowly by this lake turnover. Does that explain a lot of things? Okay, we'll give you time to write that in. All right. Good to go on your notes? Awesome. So why is it good for the lake to turn over? So I already kind of talked about this a few times. So it brings oxygen to parts of the lake that need it. It brings nutrients to parts of the lake that need it. So what do I mean by nutrients? When things decompose, like who composts? Does anyone compost? No, no one composts. So when people compost, they usually put like all their carrot peels, potato peels, stuff like that, like the food waste that you don't want to throw away. You turn that in a compost, and it turns into really rich soil. And so that usually comes from decomposing plant material. So at the in the bottom of that lake, a lot of that stuff is decomposing. All the dead plants have made their way and sunk to the bottom of that lake. It decomposes, and all those nutrients get brought back and put back into the water. And so, but it stays at the bottom. Once you have that lake turnover, those nutrients like phosphorus and nitrogen are going to be brought back up to the top, and it's going to help the plants that are up there grow. Do you have a question, David? Uh-huh. Uh-huh. Yeah, so fermenting is actually it's breaking down those sugars that are in that peel, that any sugars that are in there. Once it ferments, it turns it into alcohol, and that's right before it right before it rots. Okay, so fermentation, there's a fine line between fermentation and rotting. And so once you get to that point, that's when you have to try to filter and clear out that alcohol in order to use it, because that's what you're talking about there. But fermentation is just that first step of decomposition. And so once it starts decomposing, then you can start breaking those bits apart, and that's when the composting, the good composting, happens. Okay, thanks for that. So someone was asking about fermentation and some of that stuff. So again, all of these things, oxygen and nutrients, are vital for a vibrant ecosystem, because you need oxygen, you need these nutrients for these plants to grow. Okay, and that's pretty much it for today's lecture. What I'm going to do is I'm going to stop recording.